Okay, everybody, uh, we were talking about the skeletal tissue. We have finished the first part of the skeletal tissue. Today we'll talk about the second part. In this part, we'll talk about the structure of the bone, ossification. Ossification is the process of bone formation, how the bones are formed in the body. That is called ossification. There are two ways of bone formation. One is called interchondral ossification, another is called intramembranous ossification. We'll talk about those. Then we'll talk about the blood supply of the long bone. Hormones work on the bone, and the hormones regulate the calcium in the body. So there are two groups of hormones. One group of hormones work on the bones, come from another outside and work on the bones to grow the bones. That is one type of hormones, okay? Help to grow the bones. Another type of hormones, they have to regulate the calcium in the blood. So we'll talk about both types of hormones. First, structure of a compact bone. A compact bone is actually formed by many columnar structures like this. Many columnar structures are bundled together like this. This is the compact bone. Make sense? And each column is the structural unit, which is called the osteum. Should I give the lecture, or you just run the slides? You can write it down. Okay. So, the compact bone is formed by what? Bundle of columnar structures, right? Like this. And each columnar structure is the structural unit of the compact bone. And it is called the osteum. So this is what? An osteum. Is it clear? So many osteums are bundled together. Now, if you make a cross section like this, cut it like this, what you will see? You will see many circles, right? So let's draw that. If you see the compact bone under the microscope, you have already seen in the lab many round structures. Each is an osteum. So these are osteums. Now if I see the structure of an osteum, in the center there is a canal that is called what? Central canal. You already know that. Central canal. In the central canal, you have the blood vessels, arteries, veins, and nerves. So, blood vessels and nerves pass through the central canal. That's why we say that bones are vascular. Bones have blood vessels, right? So, central canal in the center of the osteum that contains the blood vessels and nerves. Now, around the central canal, you have lacunae, small cavities like this. So these are lacunae, tiny cavities. Okay, and inside the lacunae, you have mature bone cells called osteocytes. You already know that. So this is the osteocyte sitting inside the lacunae. It's osteocyte. So we can say that lacunae contains osteocytes. Okay? lacunae containing osteocyte. So inside each lacunae you have an osteocyte. Now, in between the lacunae, the space is filled with hard matrix of the bone that is called lamella. So lamella is everywhere, which is the hard matrix of the bone. Okay, which is the hard matrix of the bone, and lamella gives the hardness of the bone. You know, bone is very hard, and it is given by lamella. Okay. Some places you will see AE, some places you will see only A. Same thing for lacunae. Okay, both are correct. Another thing you will see, the lacunae are connected to each other by fine hair-like channels, thin hair-like channels, like this. Central canal to lacunae, as well as lacunae to lacunae. And these fine channels take the nutrition and oxygen from one lacunae to another to keep the osteocytes alive. And these are called, these fine channels, hair-like fine channels, are called canaliculi or canaliculi. Okay? Fine channels connect the central canal to lacunae or lacunae to lacunae. So the nutrients and oxygen can move from one lacunae to another to keep the osteocytes alive. Okay? So that is the structure of a compact bone. Is it clear? So here you see they have shown the lamella only. And if I connect like this, you see this is one circle of lacunae, this is another. They are very nicely organized like this, like circular way. So this is lamella, this is another circle of lamella, this is another circle of lamella. That's what they have shown here. Okay? And that's the central canal, this one. Blood vessels and nerves. Again, you see here osteon, central canal, right? And these are lacunae containing osteocyte. Here you can see better. These are osteocytes within lacunae. Here you can see lacunae only, those tiny cavities. Okay. In a spongy bone, we don't see that kind of structure. In a spongy bone, we have many broken osteons, not complete. We see many incomplete osteons in spongy bone and trabeculae. So just know that if I ask you the structure of a compact bone, this is the structure of a compact bone. Okay, these are the structures you will see in the compact bone. Spongy bone do not have any, complete osteons inside. Chemical composition of bone. Bone has both organic and inorganic chemicals. Both organic and inorganic chemicals. Now write it down. Organic chemicals are called osteoid. So osteoid is the organic part of the bone. And mineral salts are inorganic. Salts are inorganic. Osteoid is secreted by the osteoblasts. In last class, you must remember, I said osteoblasts are what? Young or old?
Young.
Young. And they secrete the osteoid. the matrix. Okay, so osteoid is the organic matrix secreted from or by the osteoblasts that I mentioned in last class too. Now, matrix contains fibers and ground substances. So, matrix is called osteoid and it contains fibers. What kind of fibers? Collagen fibers. And ground substances. Okay? Ground substances includes proteoglycans and glycoproteins. Okay? These two chemicals. Now, the fibers, the collagen fibers inside the bone provides flexibility of the bone. Hardness, write it down, hardness is given by the osteoid or matrix and fibers give the flexibility. Okay? Now you tell me, if this is a bone, okay, this is a bone, it has lost its fibers. Fibers have been destroyed for some reason, okay? Now, this bone will easily get fractured. Make sense? Because the flexibility has been lost, gone. Make sense? So if you try to bend, what will happen? Break. Make sense? It is hard, but it doesn't have the flexibility. Now you tell me, if this bone has all the fibers, collagen fibers, the matrix is less, then what will happen? The bone will be soft. Hardness is gone, right? Because matrix gives the hardness. So hardness is gone, but fibers are there. So it will easily, get bent, but hardness is not there, okay? So that can happen. Mineral salts form 65% of the bone mass, and main mineral is the calcium phosphate. Calcium phosphate is the main mineral source. Process of bone formation is called ossification or osteogenesis. Same thing, okay? Osteogenesis, osteo means bone, genesis is formation or ossification. How the bones are formed? In two ways the bones are formed in your body. One is called interchondral ossification, another is called intramembranous. So one is intrachondral ossification, another is intramembranous ossification. Okay, the bone formation. Intrachondral. Let's talk about it. Okay. Intra means what? Inside, right? Chondro. Remember, chondro means cartilage. Chondro means what? Cartilage. Osteo means what? Bone. And chondro means cartilage. Remember, okay? So if I say osteocyte, cyte means cell, right? So osteocyte is a bone cell. Chondrocyte is what? Cartilage cell. Make sense? Chondroblast, young cartilage cell. Make sense? Osteoblast, young bone cell. Remember that? Okay. So, chondro means cartilage, intra means inside. So, interchondral ossification, bones come from the cartilage. From cartilage. intramembranous. Bone is formed from membrane. All connective tissue come from mesenchyme. Yes.
What's the difference between endochondral,
Yes.
which is on the slide, and
Endro and intra, same thing. Endo means what? Endo. Inside, right? Inside. Endo. And intra means same thing.
Okay.
Inside.
So do you
So
prefer intra?
we use both endochondral or intrachondral. Okay, same thing. Intramembranous from the membrane. Okay. Now, first I'll talk about endochondral ossification, how the bones come from the cartilage. Most of the long bones, most of the bones, you can write most of the bones of your body come from cartilage. That means by intrachondral ossification. Only few bones come from membrane. Which bones? Flat bones and clavicle. Only these bones, flat bones, example your parietal bones, occipital bones, right? They come from the membrane, intramembranous ossification, as well as clavicle. The rest of the bones come from the cartilage. First I'll talk about endochondral ossification. You need to write it down, this one, but I write, and if I ask you to draw and show how endochondral ossification occurs, you need to, write it down. So first, cartilage. You know that fetal skeleton is what? Hyaline cartilage. Very good. I like that. So what happens in fetus when the baby is inside mother's uterus? Whole skeleton is cartilage. So this is a cartilage. Okay, this is a cartilage. And this is the shaft and two ends. First, in step 1, what happens? Around the cartilage, you have a covering, like covering of the bone. Around the cartilage, you have a covering too, and this is called perichondrium. Peri means around, perichondrium. Okay? And what happens? The perichondrium becomes periosteum. So that covering perichondrium becomes periosteum. And periosteum has, you already know that, osteogenic cells. These are the stem cells in the bone, periosteum. And osteogenic cells are converted to osteoblasts. That is step 1. So around the cartilage, you have the covering that is called what? Perichondrium. Is it clear? First, pericardium becomes periosteum. And you already know from last class, periosteum has osteogenic layer and fibrous layer. In osteogenic layer, you have the osteogenic cells. These are the stem cells, and these stem cells produce osteoblasts, young bone cells. Make sense? And osteoblasts produce what? You already know. Matrix, right? Osteoid. So osteoblasts produce matrix, osteoid. Okay. So now you see here what happens. The osteoid or bone matrix is formed here. And this is called bone collar. So formation of bone collar, number one, around the cartilage. That is the step one. Okay. Now, what happens next? Those chondrocytes are located in the center of the shaft. These are the chondrocytes. Cartilage cells. They start to get bigger. Hypertrophy of the chondrocytes. So they start to get enlarged and occupy more space. So these chondrocytes get bigger and occupy more space here. Enlarge. Okay, chondrocytes enlarge, and this area is called primary ossification center. Primary ossification center. This is number two. So number one, bone collar formation. How? This way. Number two, primary ossification center is what? In the center of the cartilage, chondrocytes enlarge. Is it clear? Okay. And that area is called primary ossification center. Now let's go to next. What happens, this is very interesting, these chondrocytes enlarge, get big, and secrete alkaline phosphate, a chemical. Chondrocytes secrete alkaline phosphate. Just know that alkaline phosphate is responsible for deposition of matrix. Matrix deposition helps in bone matrix deposition. Okay? And then these chondrocytes get bigger and burst, rupture. All these chondrocytes are destroyed. So a cavity is formed here. That is called the medullary cavity. Now you see how the medullary cavity is formed. You know, inside the bone, shaft of the bone, you have medullary cavity. Due to rupture of the chondrocytes. They get bigger and rupture. Okay. Then what happens? So you have bone matrix deposition around and a cavity inside. Okay. So matrix, bone matrix is this area. Okay, bone matrix is here. Also in this side, same thing, bone matrix. Okay. And cavity. That's the medullary cavity. Okay. Next, what happens? Cartilage doesn't have blood vessel, but bone has blood vessels. You know that. So what will happen? a blood vessel will enter into this newly formed bone and branch like this. Okay, so this is the blood vessel, because bones need blood supply, blood vessels. So the blood vessel will enter into the medullary cavity through the shaft of the bone and will branch both ways. Okay. And the last thing what will happen, two more ossification centers will be formed. These are the chondrocytes. Same way. Also here. At the both ends. These are called secondary, because primary you already got, so these are secondary. Ossification center at the ends. Okay? And same thing will happen, bone matrix will be formed around it. So bone matrix will be formed. Okay. Now, you see here, from primary ossification center, bone matrix is being formed this way, and secondary ossification centers, bone matrix is being formed that way. So they are moving towards each other. Make sense? Bone matrix is being formed in the shaft here, going both ends towards both ends, right? And from both ends, secondary ossification centers, matrix is being formed and moving towards the center. Okay? And this part, the part between this and this is called the growth plate, the cartilage. That is the growth plate. Probably you have heard this word. This is called what? Growth plates at both sides. Growth plate. This one too. And this part is cartilage, not yet bone, but this matrix is bony matrix here and here. Okay? But in between you have the cartilage, that is the growth plate, and gradually what will happen, more and more matrix will be formed like this. Okay? We move towards each other, and growth plate will get what? Thinner, smaller. Make sense? And at one point, only a thin line of growth plate will remain there. That is hyaline cartilage. And that will never be changed. It will always remain as hyaline cartilage, as a thin plate. Okay? And that is a weak point of the bones, where inside you will see thin plate of cartilage. Okay? Where fracture occurs often. Okay? In another place, the cartilage will never be converted to bone matrix, that is at the both ends. At the both ends, this part will never be converted to bone matrix. Always remain as cartilage. Articular cartilage, you already know, at the joints. So, articular cartilage. You already know this, right? When you draw the joint, remember, the end of the bones are covered by hyaline cartilage, articular cartilage. Okay, so this is how the bone is formed from what? Cartilage. Okay, so let's quickly review. Endochondral ossification is the formation of bones from what? Cartilage, right? Hyaline cartilage of fetal skeleton. You know, whole fetal skeleton is hyaline cartilage, right? Okay. Most of the bones of your body are formed by this way, endochondral ossification. Few bones are formed by intermembranous ossification. Which few bones? Flat bones and clown bones. all other bones come from endochondra, right? This way. Okay. So this is a cartilage. Okay. Around the cartilage, you have a covering that is called perichondrium. Make sense? Chondrium, cartilage. First thing what happens, the pericardium becomes periosteum. Make sense? And you already know periosteum has osteogenic cells, stem cells. Clear? So osteogenic cells will produce osteoblasts, young bone cells, right? And you already know osteoblasts secrete what? Matrix, produce matrix, right? That is osteoid. So around the cartilage, you got matrix of the bone, and that is called what? Bone collar. Makes sense, right? Okay, so that is first thing. Then what happens? In the center of the shaft of the cartilage, chondrocytes start to do what? Small or big? Big, enlarge, right? Hypertrophy. And that area is called what? Secondary ossification center. Make sense? And these large chondrocytes secrete a chemical that is called what? Alkaline phosphate. Make sense? And alkaline phosphate helps in what? Matrix deposition. So matrix will be deposited. Make sense? Now, next step is very interesting. The chondrocytes, after secrete alkaline phosphate and matrix deposition, chondrocytes will get what? Bigger and bigger further, right? And at one point they will burst, rupture. So what will happen? A cavity will be formed, right? That is called the medullary cavity. You know, inside the bone you have medullary cavity, right? So that's how the medullary cavity is formed. Then bone needs what? Blood supply. So blood vessel will penetrate, okay, through the shaft, middle of the shaft, and will branch, okay. And in last step, what will happen? Two more ossification centers will appear. Where? At the ends, and will deposit matrix again, right? Now matrix is being formed in the shaft and going towards both ends, right? Like this. And from both ends, matrix is being formed and moving towards the center. And in between, you still have cartilage, right? That is becoming bone, matrix. And that is called the growth plate. So the growth plate gradually gets thin, right? Thinner. And at one point, it will become very thin, like a thin sheet or thin plate, okay? And will remain there like that. This thin growth plate will never be converted to bone. It will stay like that throughout the rest of your life. Make sense? Yes.
Is that the one that gives us kind of like an anatomical neck?
It is in that area, in that, but all long bones have that, not only in humerus, okay? Inside. From outside you don't see that thin plate of cartilage, right? But inside you have around here. Make sense? And that is a weak point, right? Fracture can occur easily there. And that happens. That is called epiphyseal fracture. Okay? And this thin line of growth plate that remains as cartilage is called epiphyseal line or plate. And at both ends also cartilage will remain as cartilage, hyaline cartilage, that is the articular cartilage to form the joints. So that is how the bones come from the cartilage, interchondral or endochondral ossification. Okay? So now we'll talk about intermembranous ossification. So if I ask you, show me how the bones are formed by endochondral ossification, you will just draw these and mention these. Okay? intramembranous ossification occurs from the mesenchymal membrane, embryonic membrane. This is mesenchyme. Membrane, and these are mesenchymal cells. Okay. So first what happens, some cells, those are located in the center of the membrane, like these cells, they become osteogenic cells. Same way actually, and osteogenic cells become osteoblasts. So now these cells turn to what? Turn to what? Osteoblasts. So these are osteoblasts. Young cells, healthy, big, okay? And you already know, osteoblasts secrete what? Everybody? Osteoblasts secrete matrix, right? So these osteoblasts will secrete matrix around them in that area. This matrix is soft initially because they are secreted. Then become what? In the bone, the matrix is soft or hard? Very hard. So this matrix will become hard, and that is the lamella. You know that. Okay? So hard matrix around the osteoblast. Then what happens? Osteoblasts get older, right? Osteoblasts get older and become what? Old bone cells are what? Osteocytes. Osteocytes are mature bone cells, okay? Osteoblasts, sorry. In last class we talked about that. Osteocytes are mature and osteoblasts are what? Yeah. So osteoblasts will get older, right? And will become what? Osteocytes. Shrink, get smaller. Okay. When we are young, we are healthy, right? When we get old, body shrinks. Same thing happens here. So these osteoblasts will get smaller. But remember, the matrix is already hard. So what will happen? The osteoblast will get smaller. Osteocyte. Now around that, you have hard matrix. This will get smaller. Let's make it smaller. Osteocyte. The processes. This one got smaller, mature, osteocyte. Now you see, this is the hard matrix and this is the osteocyte, and there is a space in between, right? Because osteoblasts got smaller. So that is the lacunae. So that's how the lacunae are formed. And osteocyte is inside the lacunae. You remember the structure of the bone. So this is osteocyte in lacunae. Make sense? Now do you remember first today I showed you the structure of the pubic bone? You have the osteocytes in lacunae, tiny cavities. That's how, the cavities are formed and osteocytes are trapped inside, the cavity. So then rest part of the membrane will do the same thing. So the bone tissue will be formed. Okay. So that's how the intermembranous ossification occurs. Okay. Quickly repeating, intermembranous ossification occurs in a membrane that is called the mesenchymal membrane. Everybody following? Okay. And inside the mesenchymal membrane, you have the embryonic cells, the osteogenic stem cells, and they become osteoblasts. Osteoblasts are healthy cells, secrete matrix, and that matrix becomes hard lamella. Okay? And osteoblasts get old and get bigger or smaller? Smaller, right? Now you have hard matrix around, right? And you are getting smaller, so a cavity space will be formed in between. Make sense? So that is the lacunae. Okay? So you got the matrix, hard matrix, you got the lacunae, you got the osteocyte inside. That is bone. Okay? That's how the bone is formed in intermembranous ossification. Okay? So those are the two ways how the bones are formed in the body. Okay? From the fetal skeleton. Blood supply of a long bone. A long bone has three sets of blood vessels: nutrient blood vessels, metaphyseal blood vessels, and periosteal blood vessels. Okay? Those are three sets of blood vessels in a long bone. So now, again, this is a long bone. Around the bone, you have periosteum. You know that, the covering. So this is the periosteum. Okay. So, blood vessel that supplies blood to the covering of the bone, that is called the periosteal blood vessels. Makes sense? Periosteal artery and vein. So this is periosteal blood vessels. Another blood vessel that I showed you in interchondral ossification, that enters through the shaft and enters into the medullary cavity. Do you remember that? When the bone is formed? This one goes inside the medullary cavity through the shaft and branches. This is called the nutrient blood vessels. Okay? And another blood vessels enter through the epiphyseal plate area. Remember, between head, end, and the shaft. The epiphyseal plate is here, you must remember. The thin cartilage through that area. That is called metaphyseal vessels. Okay? So, those are three sets of blood vessels. S-E-A-L, sorry. S-E-A-L. Okay, metaphyseal vessels. So, three sets of blood vessels. Periosteum gets blood supply from periosteal blood vessels. Very simple, right? Its name is periosteal blood vessel. And through the middle of the shaft, the one enters into the medullary cavity, that is called the nutrient blood vessels. Clear? And through the epiphyseal plate area, that means between the shaft and the end, through that area, metaphyseal blood vessels enter. Now, if I ask you a simple question, that the ends of the long bones get blood supply from which blood vessels? Metaphyseal. Make sense? The end part. The middle part, nutrient. And the covering gets blood supply from the periosteal blood vessels. Make sense? So this is 1, 2, 3. Okay? So that's how the long bone gets blood supply from the blood vessels. Okay. Here, you see nutrient, artery and vein, nutrient blood vessels entering into the medullary cavity, and metaphyseal. And if you see the periosteum, this is the covering periosteum. You have blood vessels here. That's the periosteal blood vessels.